So maybe a quick reminder first. So let's do sort of a little summary, okay? So first of all, the derivative f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. Then we said that there are some techniques. The first one is the linear properties. Tell me that if f of x is equal to a sum of functions, then derivative is equal to the sum of the derivatives. Okay, same thing for minus. Okay, that's the first rule. The second is that if f of x is a constant times a function, then the derivative is equal to the constant times the derivative of u. Okay, then we did the power rule. The power rule tells me that if f of x is equal to x power n, then the derivative is n times x to the power of n minus 1. Okay, and that's how far we went. We didn't do anything more than this. We did some examples on this and we proved the linear properties, right? We proved both of them, right? I think we did.
Yeah, we did.
Okay, good. So let's go now to the power rule. Okay, so now this is, sorry, the product rule. So this is new now. Product rule. So this is how it goes. So now if f of x equals to a multiplication of two functions, so product u of x times v of x, then f prime would be what? So we're expecting this to be u prime times v prime, just like we did with plus and minus, right? We just did u prime plus v prime. Here we expect it to be u prime times v prime, but that's not going to be the case. Okay, it's going to be u prime times v plus u times v prime. Okay, so that's weird, but that's what happens in the case of the product. If you want to find the derivative or multiplication of two functions, this is how you derive. Okay, and we're going to prove this, but before that, let's do a few examples to see how this works. So example, find f prime of x. So first, so let's say f of x is equal to 7x4 multiplied by x3 plus x plus 1. Okay, so how do we find f prime of x here? Okay, so this is u of x, this is v of x, because I recognize a multiplication here. Okay, so I have to do u prime, so 7x prime, right, u prime, times v, which is x3 plus x plus 1, plus u, which is 7x4, times v prime, so v prime, so x3 plus x plus 1 prime. That's the idea, okay? So this is like, this is u, and this is v. Okay, so u prime times v plus u times v prime. Any questions? And then at this point, I just have two easy derivatives to find, which is 7x4 and x3 plus x plus 1. So this term and this term, these ones are dead. Finish. There's no more derivatives. I'm just going to recopy them till the end. But this I need to evaluate. So this is 28 times x cubed. Okay. This stays x3 plus x plus 1. This is 7x4, and this is 3x squared plus 1. And that's it. That's how you evaluate it. Is there any questions?
You don't expand that after?
You could, but right now, I'm not too much interested in the algebra, right? I know you know how to do this. At this point, to simplify this and expand, it's a high school problem. Okay, I could have expanded at first also and then derive, but I'm interested in finding the derivative. Okay, so that's f of x. This function now is f prime of x. So I'm interested in finding f prime. Simplifying it, we'll talk about it later.
Okay, thank you.
Okay, so I'm not expecting it for now. On the test, I will tell you, do not simplify your answer, or I will tell you, simplify your answer. I will specify it. Okay, number 2, let's do just one more, because I think you're getting the idea. Okay, so I'm going to let you try it. So f of x is equal to x plus root x multiplied by 1 minus 4x5. Okay. So u prime, so x plus root x prime times the second one, 1 minus 4x5, plus the first one, which is x plus root x, so u, times the derivative of the second. Prime. Okay, and then I just have two little derivatives to evaluate, which are pretty easy since we know the linear properties and we know the power rule. So this will be 1 plus 1 over 2 root x, we've done this before, times 1 minus 4x5 plus x plus root x times, and this is negative 20x4. And that's my answer.
So can we do this in one step?
Yes, you can. I don't suggest that you do it yet. Okay. I definitely skip this step here for sure. I go straight to the answer in both cases. But eventually, when you're comfortable, you could do it. Like on the test, by then I think you'll be comfortable and you'll be able to do it right away. But for now, I suggest that you do this. Okay. Especially when we're going to be doing the chain rule, maybe next class. So you'll see that it's very important to do it this way at first. Okay, any questions? Would you like another one, or could I move on to the proof? Anybody needs another one? Okay. So let's move on to the proof right away. All right, so proof. What am I trying to prove is that if f of x is equal to a product of two functions, this implies that f prime of x is equal to u prime. So the derivative of the first times the second plus the first times the derivative of the second. This is what I'm trying to prove. Okay, so anytime you want to prove something for derivatives, we go back, okay? We go back to the definition. So limit, so f of x, we said was u of x times v of x. So f of x plus h is u of x plus h times v of x plus h. That's okay. Okay, so f prime of x will be limit as h approaches 0 of, we know that it's f of x plus h minus f of x over h, which is limit as h approaches 0 of, so f of x plus h is this thing here. So ux plus h, vx plus h minus ux vx. And all this over h. Okay, who's got questions until here? Okay, so at this point, we have to be a bit creative now. Okay, so equals, I'm going to do it here. Limit as h approaches 0. And now on top, I want to do u of x plus h times v of x plus h. And minus u of x times v of x. You see that I left a big space in the middle. Okay, so I'm leaving a space because I'm going to add something and minus something here. Okay, so I'm going to minus u of x times v of x plus h, and I'm going to add it right away, right after. U of x, v of x plus h. So I minus, then I plussed it, so I did not change anything in my fraction.
Sir, can you explain it again, please?
Sure. Which this step here or before?
The one in blue.
Oh, this one here? Okay, so
Yes.
what I did, I just rewrote this expression. I rewrote it here. But the only thing I did is I added and minused a term. Okay, the same term. I added ux vx plus h. I minus ux vx plus h. So I did not change the value of the numerator here. I just added 0. This is 0. They cancel out these two. You understand?
Yes.
Okay, now, the question you could ask is, how did I come up with this? That's a good question. How did you come up with this? Adding, subtracting this? I could have added and subtracted anything. You're right. Okay, but you'll see eventually you'll develop sort of an intuition of what to add and subtract. The same way you multiply by conjugate, the same way you multiply when you see 1 minus cos, you multiply by 1 plus cos, because you recognize it's going to become sine squared. So the same argument happens this. Okay, you won't have to do this a lot. Okay, I don't think you'll have to do it in this course. Okay, just for this proof and the next proof. Okay, but other than that, that's not the point of the course. Okay, so just for now, what you need to understand is that I did not change anything in the numerator, so this expression is still equal to this. Okay, so now what do we do? Okay, anybody else have a question on this step? Okay. So limit h approaches 0, and now you're going to see why did I do this? Because if you reckon these two terms, the first two terms, I have v of x plus h in common, so I could extract it. Okay, I could factor it out. So on the top, I will have u of x plus h minus u of x. All this times I'm factoring out v of x plus h. That's what I have on top for these two terms. Plus And now in here, I could factor out, in these two, I could factor out a u of x. U of x times what's left? V of x plus h minus V of x. And on the bottom, everything's still over h. Okay, so who has questions with this step?
Me.
What's
I don't
that?
understand it.
Sorry?
Michael.
Okay, you don't understand the last step or the step before?
Yeah, the last step.
Okay, so the last step, the only thing I did is I factored out from these two terms, this and this, there's a V of x plus h in common, here and here. So I factor it out. Okay, so if you were to redistribute it, you'll get back to what you have on top. Same thing, if you redistribute it here, you'll get back to what you have on top. You see it now?
Yeah, I see it.
Okay, good. Okay, so nothing, I didn't change anything. All right, so let's continue. Okay, so equals, so now I have one big term plus another big term, so I'm going to separate the fraction in two fractions. I'm going to put this term over h, this term over h. Okay, so I'll limit h approaches 0, so the first term, ux plus h minus u of x times v of x plus h, all this over h. So I'm just going to put this one over h, doesn't matter. This or both, doesn't care. As long as you write the h once. Plus, same thing here, u of x times, and I have vx plus h minus v of x, and all this again over h. Okay, so this is the limit of all this. Any questions? Okay. And now what I'm going to do is I'm going to apply the limit on each of the terms. Okay, so equals limit as h approaches 0 of this fraction. So u of x plus h minus u of x over h times limit of this one here. Limit h approaches 0 of v x plus h plus limit of u of x. Limit h approaches 0 of u of x times limit h approaches 0 of the last fraction here, vx plus h minus vx over h. Okay, so I just applied the limit on each term. Any questions? Okay, so at this point, we're almost done. Do you recognize this? U of x plus h minus u of x over h, as h approaches 0, what is that equal to?
U prime of x.
Yep, that's u prime of x. Times, when h approaches 0, v of x plus 0 is just v of x. Plus, well, u of x does not even depend on h, so it's just u of x times, and this same argument, this is v prime. And that's it, I proved. I just showed that f prime of x is equal to u prime times v plus u times v prime. I'm done. This is the proof of the product rule. Any questions? Okay, let's go to the quotient rule. Okay, so I'm gonna write down the quotient rule, apply it with examples, and then prove it. Same thing we did as the product. Okay, so let's go. So the quotient rule okay, is as follows. So if f of x is now a quotient, so division, u of x divided by v of x. Okay, then the derivative will be, so u prime times v, this time it will be minus instead of plus, u times v prime, and then everything divided by the denominator, so v of x squared. This is the quotient rule. Okay, so this you have to remember in your sleep. I could wake you up in the middle of the night, you have to be able to give me this. Okay, because you're going to use it every time throughout the course. Okay, let's do a few examples on how to apply it. So find
The denominator is V or U?
excuse me?
The denominator is V or U?
It's a V. V. Okay, so try one here. F of x equals to, let's say, x2 over x3 plus 5. Okay, so using my rule here, so it's a derivative of the top. So x2 prime times the bottom, x3 plus 5, minus the top times the derivative of the bottom, divided by the bottom squared. Okay, you get this? It's really not difficult how to apply it. And so now I end up with just two derivatives to evaluate. Okay, until now I did not evaluate any derivative yet. I just put the structure, right, of the answer. And now I have two derivatives to evaluate these two. Okay, so that's equal to, so this is 2x, we know, times x3 plus 5 minus x2 times, and this is going to be 3x2, and all this over x3 plus 5 to the power of 2, and that's my answer.
Sir, how did you get the 2x?
The derivative of x2 is 2x. You know why?
Is it the
Power. Bring the 2 in front, and then minus 1 from the exponent.
Okay.
Okay. 2 f of x is equal to 1 minus 2x cubed divided by x4 minus 1 plus 1, x4 plus 1. the derivative of the top times the bottom minus the top times the derivative of the bottom. And all this over the bottom squared. Yeah, that's it. Equals, so this derivative is negative 6x2 times x4 plus 1 minus 1 minus 2x cubed times, and this is 4x cubed, and then all this over x4 plus 1 power 2, and that's my answer. Did you guys get this right? Okay, you guys are not answering, so I'm guessing that it's okay. Okay, so I'm moving on. Let's prove it. So proof that if f of x is equal to u of x over v of x, then f prime of x is u prime x times vx minus u of x times v prime x over v of x squared, okay? And this is what I'm trying to prove. Okay, could somebody tell me how we would start this based on what we did with the product rule? How would you start it?
You put in x plus h.
Sorry?
You do f of x plus h.
Okay, very good. First, I'm going to write down f of x is u of x over v of x. Good. And so f of x plus h is what? Continue. Tell me.
It would be u of x plus h over v of x plus h.
Very nice. Okay, and then from here, I could find what f prime is. Limit as h approaches 0. I'm just applying the formula f of x plus h minus f of x over h. Okay, which is equal to limit h approaches 0 of what? Can you tell me?
You're talking to me?
Yeah, whoever.
Oh,
Yeah, go ahead.
so you would do u of x plus h
Yeah,
over j of x plus h.
v of x plus h. Yeah, so u
Sorry,
of x plus
v.
h over vx plus h minus,
u of x over v of x.
and all this over.
H.
Very nice. Okay, do you understand what you did? This is perfect. Okay, so f of x plus h minus f of x over h. And now I need to evaluate this limit. So the first thing I'm going to do, because I hate having fractions on top of fractions, so I'm going to find the common denominator and try to express this as one single fraction, not a complex fraction like this. Okay, so the first thing I will do is I will find the common denominator on top, and that means multiplying here by v of x and v of x on top. Okay, so I multiply here by v of x top and bottom, and here I will multiply by v of x plus h and top as well, v of x plus h, so that I have the bottom both of them are v of x times v of x plus h, both of them. Okay, so let me rewrite this nicely here. Limit as h approaches 0. And so on top now, what do I have? I have u of x plus h times v of x, and then minus u of x times v of x plus h, and all this on the common denominator, which is v of x times v of x plus h, and all this over h. Okay, who's got questions at this step? Okay, good. So now what do I have? One fraction divided by another fraction, h over 1, right? So I will just do the top times the reciprocal of the bottom, okay? The bottom flips, okay? That's how you divide fractions. So limit h approaches 0, so the top is ux plus h times v of x minus ux times v x plus h, and all this over v x times v x plus h, and then times 1 over h, or just put the h on the bottom. Okay, any questions? Okay, let's go. Let's continue. So what I'm going to do now is the same as I did for the product rule. I'm going to leave some space in the middle here, and I'm going to add and subtract something. So equals limit as h approaches 0, so ux plus h v of x, and then minus ux times vx plus h, and all this divided by h times vx plus h. Okay, so I'm going to minus something and add something. So I'm going to minus, in this case, u of x times v of x. And here I'm going to add u of x times v of x. Okay, so nothing changed. Okay, equals limit h approaches 0, and so on top, the first two terms, as you see, I could extract the v of x. So I will have ux plus h minus u of x times v of x. And here, I will extract a minus u of x times, so this term will become v of x plus h and minus v of x. So I played around with the signs because I extracted a minus. All this divided by h times v of x plus h. Okay, who's got questions so far? I'll give you 2 seconds to write. Okay. At this point, I'm almost done. What I'm going to do is I'm going to divide the top by h, and I'm going to divide the bottom by h. So here, I will divide by h, and the bottom also, I will divide by h. Okay, if you want. Equals limit h approaches 0. So the bottom is very simple because the bottom is just the same thing, but there's no h anymore. So it's v of x times v of x plus h. That's what I have on the bottom if I divide by h. And on top, if I divide the first term by h, I get ux plus h minus u of x over h. I divided it by h times v of x minus, and here I have u of x times, and I will have here vx plus h minus v of x divided by h as well. And now do you recognize? I will do an extra step. Okay, I just wanted to fit everything on one page, but it's not going to happen. So I will just do the extra step on the next page. Okay, so what I'm going to do now is I'm going to include the, like apply the limit in every term, like I did before. Okay, so equals limit as h approaches 0 of ux plus h minus ux over h times v of x, which does not depend on h, minus u of x times limit as h approaches 0, vx plus h minus vx over h, and on the bottom, I will apply the limit here because there's an h, vx times limit h approaches 0 of vx plus h.
Sir?
Yeah.
Why doesn't v of x depend on h?
Because there's no h inside. Do you see an h?
Well, above little like earlier, wasn't it over h before?
Which one? This h here?
Yeah.
Yeah, but I divided by h. I got rid of it.
And why can't you just multiply it instead of dividing it?
Multiply what?
Like you divided by h and you got rid of it by dividing it, right?
Uh-huh.
Why can't you multiply it to like get rid of it? Why is it division here? I'm kind of
Because if you
confused.
multiply it, you get h2.
Oh, okay.
Right? If you multiply the bottom, I divided the bottom by h.
Uh-huh.
So h divided by h cancel. If I would have multiplied here by h, I would have gotten h2 here. H times h is h2.
Mm-hmm.
It's not wrong, but it just leads me nowhere.
Yeah. Okay, yeah, thanks.
No problem. Okay, please ask your questions. Okay, questions are very good. So this we recognize as u prime. This is we recognize as v prime. Okay, so it's equal to, on top I have u prime x times this is v of x minus this is u of x times, and this is a v prime of x, and divided by, and on the bottom I have v of x times, and this, if h is 0, this is also v of x. So it's v of x times v of x, which is v of x squared, and that's it. That's what I wanted to prove. Proof is done. Okay, so this I already asked on the test, by the way. That's a test question that I've already asked, but of course I have shown them in class already. So I proved it in class, and then I ask it on test, prove it for me again. Okay, so this could happen also. So you have to know the proofs. Okay, any questions? Okay, good. So let's move on. So there's one more rule to do, okay, which is the chain rule. But before doing the chain rule, I'm going to show you how to derive trigonometric functions. Let me see. No, I'm going to show you the chain rule first. Okay, let me show you the chain rule first. Okay. Okay, so the chain rule is a bit more difficult. Okay, but that's pretty much the last rule. Chain rules as follows. If f of x is equal to u of v of x. So it's a function of a function. Then f prime is equal to what? So it's u prime of v of x times the derivative of the inside function, v prime of x.
I didn't understand the f of x, like the simple one.
Here,
Yeah, it's just,
it's a function of a function. It's like what you did in high school. This is like u like this. You've done something like this?
yeah.
Yeah, that's
Got
what it is. Dot,
Logging.
yeah, round,
Got-
okay? It's composition of functions,
Okay, thank you.
okay? So let me do a few examples. So we have to do a lot of examples for this for you to really understand it or get the feel for it, okay? So I'm gonna do a few before doing the proof. If we don't get to the proof today, it's not bad, we'll do next class, but I want you to understand how to derive, okay? So example, find again f prime of x, okay? So first, I'm gonna do it for you. So let's say f of x is equal to, let's say x2 plus 5 to the power of 20. Okay, so what's f prime here? Okay, so now look at this. We have the function x2 plus 5. That function is to the power of 20. Okay, so we're putting to the power of 20 another function. So we're going to first derive the power of 20. So it's going to be, as usual, 20 times this power 19, our regular power rule. Okay, so of x2 plus 5, and times the derivative of the inside. So what's inside? I have to derive it. So x2 plus 5 prime. Did you understand what I just did?
No, can you explain again?
I will explain.
So wait, so u is the exponent and v is the number inside?
Exactly. The function inside. Very good. Okay. So in our case here, I'm gonna write it in a second. Okay. But the way I see it, okay, is I recognize that what happened. I'm looking at the x. What did I do to the x? The first thing I did is I added 2. I powered it by 2. Then I added 5. Then to that I powered 20. Okay. So there's 3 steps I did to the x. Power 2 plus 5, power 20. Okay, so I'm decomposing it into 2 functions. The first function is taking the x, power 2 plus 5, 1 function. Then to that function, that result, I'm powering it 20 to the 20. Okay, so I'm going to go now from the outside, from the last function, the last step in dressing up the x. The last step is putting it to the power of 20, and I'm going to find the derivative of that power 20. Okay, so how do you derive something power 20? We know it's 20 times that thing power 19. We know that. Okay, but what's inside is not just x, it's x2 plus 5, so I have to derive this as well. Okay, if this were just x, if it was just x power 20, I would have 20x19 times x prime, but x prime is 1, so I wouldn't even need to write this. That's why we didn't write it for now, until now. Okay, but now what's inside is not just x, it's a function which I need to derive. Okay, so let me write down the answer. 20 times x2 plus 5 to the power of 19 times, and now this is 2x. And that's my answer. Okay, so this 2x here comes from the derivative of the interior. Okay, this comes from the derivative here. And you should never forget this. It's important, and sometimes you're going to forget it, unfortunately. That's what happens. Okay, do you have questions, or should we do another one? That's going to help you. Maybe we do another one?
Sir,
Yeah.
can you explain the last step again?
Just this one here?
Yeah, how did you get there?
Did you understand this one?
I don't understand where the 2x came from.
No, but did you understand what the first step, what this came from this here?
Yeah.
Well, that's it. So now the 2x is just a derivative of that. The derivative of x2 plus 5 is 2x.
But why?
Oh, you don't know why? This is why
No.
this is. Oh, because the derivative of x2 is 2x, and the derivative of 5 is 0.
Okay.
Yeah, you remember that the derivative of x2 is 2x?
Yeah.
That's it.
Okay, thank you.
Okay.
Sir, can you explain the first step again?
Explain what the first step?
Yes, please.
Sure. Okay. So let me try it. Let me try it another way. Okay. Let me go back here. Okay. So let's say here in my case, let's say u of x is x to the power of 20. And then v of x is equal to x2 plus 5. Okay, let's write it like this to go exactly the way the rule is written. Okay, so if I understand here, f of x, in our case, is equal to u of v of x. Right? Because it's equal to what? U of, so v of x is x2 plus 5, which is, so u of x is x20. If instead of putting an x here, you put x2 plus 5 in the u, then this will become x2 plus 5 power 20. Okay, so this is, if I want to rewrite my function x2 plus 5 power 20 in a composition of 2 functions, these would be my 2 functions. U will be x power 20, which is the last thing I'm applying on the function, which is the power 20, and v of x is the first thing I'm applying on the x, which is turning it into an x2 plus 5. Do you understand what I wrote just here?
Yes, I get it now.
You get it, this part, okay? So now let's do f prime. Let me just move up a bit. So f prime of x, according to my definition, it should be u prime of v of x times v prime of x. Okay, so let's see what is, I know what u of x is. Okay, so u of x is x2 So u prime of x. What's u prime of x? U of x is x20. What's u prime of x? Somebody?
20x19.
Very nice.
Like-
20x19. And if v of x is x2 plus 5, what's v prime of x?
Works.
2x. Okay, good. Okay, so here I need u prime of v of x. Okay, so u prime of v of x is equal to, so instead of having an x here, let's say I have a v of x. So it would be 20 times v of x power 19, which is 20 times, well, v of x is x2 plus 5. Is this okay? So this is this guy. And v prime is 2x. And that's how I got my answer.
I get it now. Thank you.
Okay? And that's the long way to do it, but it's good to do it technically in details. Okay? I prefer doing it right away like this. That's the way I learned it, but it's up to you. You could always do it this way. Okay, just much longer, but it's good. It's good as well. Okay, try one more. Okay, try another one. Number 2. Let's say f of x is 3 minus x to the power of 7. So what's it going to be? 7 times 3 minus x power 6 times the derivative of the inside, which is 3 minus x prime, which is 7 times 3 minus x power 6 times minus 1.
Question. Could we put
Yep.
-1 in and write
Sorry?
-7?
Yeah,
Could we
sure.
write minus?
Yeah, even if in the other question, right here, you could have done 40x. Could have combined the 2x and the 20 to make it 40x times this. Yeah, you could. I'm just not focusing on the simplification for now. I'm just focusing on finding the derivative. But you're right. This will be -7 times 3 minus x to the power of 6. You're right. Any questions? Should we do another one? We should do another one. Number 3.
I have a question.
Yeah.
For like the number 2 or any problems, when you get at the end, you get 3 minus x exponent 6.
3 minus, yeah, okay. What's your question?
Alright, I just figured it out.
Okay, good. Okay, so in this case, what I'm going to do is before doing anything, I'm going to rewrite it in exponential form, which is 2x3 plus 1 to the power of -8. And now I could do my derivative using the chain rule. Okay, so I'm going to put -8 in front. times 2x3 plus 1 to the power of -9 times the derivative of the inside, 2x3 plus 1 prime, which is -8 times 2x cubed plus 1 to the -9 times, and this is 6x2. And that's my answer. Are there any questions?